so dividing polynomials. Here's the rule. Well, first of all, when we were multiplying them, what did we have to do with our exponents? So what do you think you're going to do when you're dividing? Because they're opposites, right? So dividing with polynomials, you're going to subtract your exponents. No. These are just little rules. Here's another little rule. You can never get a negative exponent. And the other rule is we're going to just divide any whole numbers. Not with my pen. They started this last class. So it's like dragons. They did that last class, the last few minutes. I thought it was just.
Oh gosh.
No. Okay, so how do we do this? Let's say we have x to the fourth over x to the second. Just real easy. We're going to start with something. But that doesn't look all that easy, right? If we subtract the exponents, what's 4 minus 2? Okay, so it could equal x to the second power. We always take the number on top and subtract it by the number on the bottom. The exponent on top, and we subtract it from the exponent on the bottom. So let's say we want to write this out in expanded form. What is x to the fourth in expanded form? What would that look like? 4 x's, right? And what does x to the second power look like in expanded form? So now, if we cancel out the like terms on top and on bottom, how many x's can I cross out? Just like that. And so what am I left with? So x squared, what am I left with on the bottom? Not 0. It'll always be, if you have nothing left over, we're left with 1. Well, what's anything over 1? It's just whatever that top number is. So it would just be x squared. Right, you can just subtract it. I'm going to show you. It's not too bad, I promise. But what happens if we have this? Okay, so we can't have a negative. Therefore, we have an issue. Because what's 2 minus 4? Negative 2. Okay, so let's write it out in expanded form, and you'll be able to see how this works. If I write this out in expanded, we know it's 2 x's. And x to the fourth, I know is 4 x's. What can I cancel out? 2 x's again. So what am I left with? But where are they at? This time they're on the bottom. So it would have to be 1 over x squared. So the rule is always subtract top number minus the bottom number. If you get -2, which we know we can't have, we just move this to the bottom and put a 1 on top of it. That's the rule. Here's my shortcut. Subtract them. Don't worry about what's going where. What's 4 minus 2? It's 2, right? Where's the bigger exponent? So it has 1 bottom, whatever I'm left with. It's not the rule, but it always works. It's easier than having, okay, -2 than having to remember to put a 1 on top of it. If you're totally confused on it, like if you're doing a test, EOC, whatever, and you have one of these and you get totally confused, you can always write it out and expand it, and then it's obvious what has to go where, instead of trying to do it in your head. All right, so let's do a couple of these just practice problems. We're going to do remember the recording's not coming out. You guys are like, maybe that's a good idea. Okay, there's one number that's going to give us a problem. Why is the u going to cause an issue? It doesn't have an exponent. If a number does not have an exponent, again, this is a suggestion, not a rule, put a 1 there. Because if you don't, you're a lot more likely to make a mistake. Okay, so if there's no exponent, we're going to put a 1 here. So we deal with each variable all by itself, just like what we did yesterday. So we're going to do these two first. T to the 5th divided by t to the 2nd. We get t to the 3rd. Is it going to go on top or bottom? Top. Why? Because that 5's up top and the 2's on the bottom. You can even visualize it. Okay, I've got 5 t's and I've got 2 t's. If I cross them out, what am I left with? 3 of them up here. What about the u? U to the 2nd. Oh.
That scared me. I was like, what is that?
Yeah, UFOs landing.
It's not like a phone.
So would u to the 2nd go on top or bottom? Top, because that's the bigger exponent. So our simplified form is t to the 3rd, u to the 2nd, or t cubed u squared. We're going to do one like that. Let's get all this down first. Okay. Just equals just that term because the bottom was totally gone. So if I had to write this out in expanded form, what's the top going to look like? It is. It's going to be long, right? We're going to have 6 A's 4 B's and 10 C's. That's why we want to know the shortcut. But we can always go back to that if we were to get stuck. We can always go back to that and kind of write it out. So if I deal with just the A's, what's A to the 6th divided by A to the 3rd? A to the 3rd or A cubed. What about B? Now, I'll tell you, when you write your answer, we all know it's B to the 1st. But what about that 1? We want to get rid of it because if this was multiple choice, they're not going to have a 1 as an exponent there. And then what about the C's? So basically, there's just not an exponent separating B and C. Yes. You have to what? You do not have to. If you put the line and the 1 here, it's just going to be this. So the actual answer should just be A to the 3rd, B, C to the 7th. What's going to happen to the B here? Think about if it was an expanded form. How many B's are going to be on the top? How many are going to be on the bottom? So when I start canceling them out, how many am I going to be left with? We're going to have none left over. So that's totally going to be gone. It's going to be, B is gone too. We don't put B to the 0 power. Okay? What am I left with the C's? And F would be 2. Now, let's talk about this B4, because I'm going to use this one to prove another point. If I write out what would this be if they were numbers? The same on top, the same on the bottom. Could be 1. Right? If this was 2, 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So if I have a 16 here and a 16 here, what does that reduce to? 1. So we know this equals 1. But we said they would all cross out. So therefore, B to the 0 power has to equal 1. Here's a rule. And it's going to be one of those rules that hopefully you'll remember. Anything to the 0 power is 1. Because if it was 1, how's that really going to change anything? Okay, so Amelia asked a really good question. She said, well, would you put the 1 there with the C3F2? If you put a 1 there and you're multiplying anything by 1, is it really going to change anything? No. So we typically don't put that there. But you do need to remember, anything to the 0 power is 1. I don't care if it's 537,223. To the 0 power 1. No matter what. That's just going to be one of those little things that you have to remember. Right here. Didn't we say if this was 16 over 16, it would be 1? But they all cancel out, so my exponent is 0. Because you think it's b times 0. Sort of. And then we think, well, anything times 0 is 0. But it's just x1. Because they would all cancel out, leaving you with no exponent. So it means basically the same on top and bottom. How is this one different from the other ones we were doing? Well, there's no G on the bottom. It would have to just say G6. Because if you think about it in expanded form, if there's 6 G's on the top and none on the bottom, what's going to cancel out? Nothing at all. So we're going to be left with G to the 6. What about the H? And so this looks really, really difficult, but it's definitely not that bad. Because that would be a lot. So we're going to take each term, 3 to the 5th power. How do I do that? 3 times 3 times 3 times 3 times 3. 240 what? Okay. Now what about x squared? Because the 2 there is an exponent and the 5 is an exponent, what do I do with them? Multiply them together. So that would be x to the 10th power. And if you just even visualize it, x2 written out 5 different times is going to be 10. And what about y to the 3rd power? It would be y to the 15th. Because 3 times 5 would give us 15. Oh, that's not just the exponent. That's just the exponent. Over what? Not 25. What is it? Because 5 is an actual number, what do I have to do? 5 times 5 times 5 times 5 times 5. That rule is going to be the trickiest part of keeping these separated. Real numbers, we actually have to use the exponent. If there's 2 exponents, we just multiply them together. What's the answer? You shouldn't even have to write this down. What does this tell me? Anything to the 0 power is 1. Nope. If I apply this at all, it's 1.
Yesterday, mine was
You have to do anything else. No. Okay, does everyone understand that? If there is a 0 exponent applied to this whole parentheses is 1. Don't do anything else. I'm fixing to show you one where we have it sort of like that. This one is going to be a little more difficult. I'll do up front. Because on this one, not all of the bigger numbers are on top. So we start with our numbers. 2 over 4. Ignore everything else. If it's a fraction, 2/4. What does it reduce to? So 1 goes on top, 2 goes on bottom. 1/2. Basically, we just divided both 2 and 4 by 2. That's really all we can do. What about the r's? Okay, so R2 and R1. So if we subtract them, we get R1. But where is that going to have to go? Top or bottom? Why on the top? Because the bigger exponent is up top. And remember, we're just going to do R. We don't have to do R to the first. Now, what about that V to the 0? It's just 1. Now, if we're multiplying, do you think I need to stick that 1 in there? No, we don't. So we're just basically going to ignore that. Now, what about the T's? What's 7 minus 5?
What did you do 5 minus 7?
Well, remember, if we do 5 minus 7, what do we get? And if it's -2, what do I have to do with it? We got to put it on the bottom. But remember, the little shortcut is to do the biggest number minus the smallest, which is 2. Where's the bigger exponent? So that tells me t to the 2nd power needs to go on the bottom. You just have to be careful where you place everything. You don't have to put the 1 exponent. Remember, that's sort of invisible. Okay, now I'm going to probably blow your minds. Warning. Okay. Now, I know you're going to go, I thought we couldn't have what? Negative exponents. Not no solutions. We like that because those are the easy ones, right? Oh, we can't get over that one. Okay, here's what we have to do. If we have negative exponents in our problem, we're just going to flip-flop around where they're at. Okay, let me rewrite it to show you. It will be took this negative exponent, and because it was on top and the negative, I automatically, my eyes are drawn to that. I need to take care of it. It's got to go wherever the opposite is. So if it was on top, it's got to go down on the bottom. This is also a negative exponent. But since it's on the bottom, I need to move it to the top. So we just rewrite our problem. Can we simplify anything here? There's absolutely nothing that can get crossed out. Why? The variables are all different. Would you have ever thought when you walked in here 11 weeks ago that you would even have a clue how to solve a problem like that? No. It's kind of neat when you think about like how much you've learned so far. If I'd have put this up on the board the first day of school, y'all probably would have walked out and went to the students and said, no thanks. So do we have any negative exponents? So before we do anything, we have to deal with those. What about the negative 8? Is it an exponent? No. So as long as it's not an exponent, we're okay. If it's just a regular plain old number, it's going to stay there. So if I rewrite this, what's it going to look like? Okay, let's talk about Z. Because there's already a Z2 down here. Okay, all I did from here was I got rid of this because of the negative. Right? So we got to take this and it's got to move down here. So if I already have 2 Z's on the bottom, right? And I move 4 more Z's to the bottom. How many Z's are on the bottom? 6. No matter what, we're adding those numbers. Doesn't matter, positives, negatives, whatever. Because think about it, if this were expanded form, how many Z's would you write? And if this were expanded form, how many Z's would you write? And if you took these 4 and you moved them down here, how many would you have?
Okay.
Can we simplify anything? Can we simplify anything? Yes?
Yes.
Gentlemen, are we paying attention? So start with this. Plain old numbers. Negative 8 over 4. How can I simplify that? Okay, do I need to put the 1 on the bottom? I am, just in case I have nothing else left down there. Just for the time being. What about our x's? So 3 minus 2 is 1. Where's the bigger exponent out here? So it would just be x. What about the y's? So this is y2, y3. And remember that has a little invisible 1. So what's 3 minus 1? 2. And where's the bigger one at? Is 3 or 1 big? So y2 has to go on top. And then what about z? Really not anything I can do with that. So it would be -2 y squared over x times z to the 6th. Right. We put it there just in case we have no variables left on the end, just to kind of hold a spot. What do I do with that negative? It doesn't disappear. I'm not a magician, can't make that happen. What we're really doing is that negative attached to the 5 or the 8? It basically means the whole thing is negative, right? So, yes, so it just stays right out there in front. Never, not going to mess with it at all. Stick it back in the front. Absolutely. Okay, so now that you know what to do with that negative, see if you can simplify this problem. It's okay, we're going to be working on this for a couple of days. This is not a one-day lesson. Definitely not a one-day lesson. Yes, the same, all the same rules still applies. Who can tell me what they came up with? Who's gonna be brave? Dan's like, not. All right, Megan will be brave. Tell us what you got.
5 over 8, and then 8 2 on top, and on the bottom 2
Everything is exactly right. You just gotta stick the negative back in front.
Okay. It would be good if I remember the
Can't reduce them to this. Yeah. Don't divide 5 and 8 and come up with a decimal. We want a fraction. You can't reduce it. Leave it alone. All right, last one. Okay, while you're working this out, I want to talk to you real quick about tomorrow. You work, well, just kind of listen as you're working. When you come in tomorrow, Mr. Wilkerson, Doc will be in here. And he's just doing my evaluation tomorrow, just to make sure that I'm not in here. We're not just goofing off and playing around and acting like a bunch of idiots. So here's my only request: act like he's not here. Okay? I don't put, for those of you who have me in 5th grade, I'm not putting on a show. We will do just like we always do every single day. So don't, just act like he's not here. Don't sit there and go, oh, I can't say it. It's not a big deal. But he's just here to make sure that I'm teaching what I'm supposed to be. Okay? So when he's here, he's going to sit in the back of the room, just totally ignore that he's in the back there and go on about your day like you want to do it. He did that to me the other day. He came in and sat down in the back of my class, and I had someone sitting where RJ is. It's really, really tall. And he just kind of snuck in behind him. And he was up there for like 15 minutes. I was like, oh, I didn't even see you come in. He's like, we're here for a while.
We were in Mr. Tanner because I wanted to know something he was like. Yeah, that's what I was just telling. He came in to evaluate Mr. Tanner the other day, and Mr. Tanner talked the whole period, and you could tell that he was yelling at board. It was.
Well, like I said, we're not putting on a show. I don't have any special lesson. It's gonna wow him. It's just a regular old day. We're working on what we've been working on. Okay, so. Okay, good question. Totally back to what we're supposed to be doing. What has to happen to that y negative 3? We gotta move it to the bottom.
Yeah.
So we should end up with x to the 3rd over 2y to the 3rd.
I put a 1.
Okay, you have a 1 here?
Yeah.
I'm okay with that.
So, would that be right?
It'd still be right. So if you reduce 2/4 to 1/2, and then you put your x3, y3, I'm good with a 1 in front of the x to the 3rd. I mean, eventually you need to recognize that that needs to disappear, but for the first day,
Is it still negative 3 when you move it down?
it's not. That's why we're moving it. Because we need it to become positive, so we have to move it.
Okay. Okay, how does that work?